Welcome to Operations Research Monte Carlo Simulation using MS Excel lecture series by Professor Joyjeet Ghose. This is the first lecture of a 4-lecture series. This lecture will be on what is simulation, introduction to Monte Carlo simulation, need or application of Monte Carlo simulation. He will also be explaining the application of Monte Carlo simulation using an example in MS Excel. The application is explained with generalized example and anyone can understand easily. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture series on Monte Carlo simulations. So in this series of lectures, we'll be using Excel or rather MS Excel to solve the problems or simulate the particular problems that we'll be discussing. Now, I have seen my personal experience, if you are not able to actually simulate the problems, manually doing the problems won't give you the essence of simulation. But however, in the class, it is very difficult to do programming and to simulate the problems. So therefore, I have found a unique way of using the Excel, MS Excel, just to simulate the problems. And I found the students are very interested in solving this kind of problems. Of course, in real life problems, you will not be using MS Excel to solve or to simulate the problems. You will be using various types of computer applications or programs to actually simulate the problem. But however, to understand the concept of simulation and to feel the essence of simulation, we will be using MS Excel. And this is a very unique way which I have developed. I hope you will like it. So let us not waste any time and start with the problem. So first we'll discuss what is simulation, what is Monte Carlo simulation. And then with a particular problem, I will explain the concept of Monte Carlo simulation in this particular lecture. In the next 3 lectures, you will be getting an idea how to use Monte Carlo simulations for business problems. So let's start here. So what is a simulation? Simulation is basically a representation of reality through use of a model or device. Now it may be a computer simulation, it may be any other kind of simulations also. So it's basically a representation of a real life problem which will react in the same manner. The model so developed has to react in the same manner under a given set of conditions. So that is the concept of simulations. Now what is the need of this simulation? Now sometimes the real world problems are very difficult to represent mathematically or to understand the physics of the problem or maybe the physics of the problem is not known to us. And the problem may be stochastic in nature, and those are difficult to solve by conventional methods. And such problems are ideal candidate for simulation. So this kind of tools, that simulation tools, becomes a important tool for tackling complicated problem for managerial decision. It's not only for managerial decision; it is applicable for any kind of real world problem. It may be a science problem, it may be a business decision making problem. So any kind of problem you can apply. So as you solve more problems, you will be able to understand what are the areas of applications. So what are the advantages? It is used to analyze large and complex problems which cannot be solved by other methods. So therefore it is a highly advantageous in such a situation, and sometimes it may be the only solution that is available. And and it helps in identify which of the parameters or which of the variables in the particular process are important ones and are affecting the process. So that is an important aspect of simulation. With using simulation, we can identify what are the variables in the particular problem which are important or which are major. And once you construct this simulation model, it can be used again and again to understand the physical problem. But however, every good thing has certain limitations. So what are the limitations here? Now sometimes your simulation is as good as your understanding of the process. So if sometimes it's not possible to identify the variables, in such cases you may not have a good simulation. And sometimes it is very difficult to program large and complex problems, and of course some large problems requires use of high-end computers and computational time, so that is also and limitations. And all the solutions that you will be developing will be unique and will be applicable only for that particular problem. So it is not a generalized solution. So every time you want to simulate a different process, you have to develop a different model. So these are the limitations of simulation. So with this understanding, I think we should start with Monte Carlo simulation. What is a Monte Carlo simulation? So Monte Carlo simulation is basically a computer-based or computer algorithm or computational algorithm that rely on repeated random sampling. So here I emphasize the word random sampling. So random is very important here to obtain a numerical result. The essential idea is using a randomness to solve problems that might be deterministic in principle. They are often used in physical and mathematical problems and are most useful when it's difficult or impossible to use other approaches. So here we will be using random numbers to generate a statistical distribution functions. And this type of problem, this type of technique is used for solving problem which are mainly stochastic in nature. Such type of problems are most suited. You can use Monte Carlo for solving some physics problems, you can some mechanical problems, or for any kind of business decision making problems. Monte Carlo simulations can be used. Our focus will be mainly in application of Monte Carlo in business problems in solving business problems which are stochastic in nature. And Monte Carlo simulation is a solution which are very close to the optimal, but not necessarily the exact solution. You cannot find an exact solution by Monte Carlo simulation, but it will be very close to exact solution. But that depends on the number of trials. The more the number of simulated trials, more you will be close to the actual solution. So here is very important how many trials you make. So the simulated trials are very important. So how do you solve simulation problem? First define the problem, then construct the approximate models. I'll discuss steps with an example. Like this you will not be able to understand. Okay, now history of this is very, very important, very, very interesting rather. This person called Stanislaw Ulam, he was recovering from certain illness in 1946, and he was staying at home alone, and he was playing solitaire. Now he wanted to find out what are the chances of his winning, and he found that mathematically it's very, very difficult or rather impossible to calculate the chance. So he wanted to carry out experiments and find out what are his chances of winning each time. So but to carry out the actual experiment will be taking huge amount of time. So he wanted to use computer algorithms to simulate the experiments, and he described the idea to this person, John von Neumann. You might have heard the name John von Neumann, and they had an ENIAC computer at that time. It was one of the best computers available to carry out the Monte Carlo calculations. And later on, John von Neumann found that this is a very, very important tool and a very strong tool to solve some difficult problems which cannot be solved by other means. So they were basically physicists at Los Alamos Scientific Laboratory, which was investigating radiation shielding and the distance the neutrons would likely to travel through the various materials. And they have used this technique to successfully predict the distance moved by the neutrons. And later on, they were working in this Manhattan project, which you might be knowing about the Manhattan project. So both decided to use this simulation technique in the Manhattan project. However, it was a very secret project, So they wanted to give a name, and a colleague of von Neumann and Ulam, Nicolas Metropoli, suggested using the name Monte Carlo, which refers to the Monte Carlo casino in Monaco, where Ulam's uncle would borrow money from relatives to gamble. So that's how the name Monte Carlo was associated with this particular simulation technique. And Monte Carlo simulation was central to the simulations required in Manhattan Project. And because of that, in the 1950s, they used at Los Alamos for early work relating to the development of hydrogen bomb. So you can say it is so powerful. This technique is so powerful that it led to development of hydrogen bomb. Anyway, that's the history part. Let's see how we can apply. We'll be seeing in the next subsequent lecture. In this lecture, we'll be discussing how to apply the technique with a very simple example. And from the next lecture, lecture 2, 3 and 4 will be devoted to application of Monte Carlo simulation in business decision making. So, or in business scenarios, different business scenarios. So let's start with an example. So this is an example of the value of pi. So we know the value of pi, it is given here, it continues. So how to calculate the value of pi? So that is the problem. So here, this is a quarter of a circle whose radius is, let's say, 1. So this is square of 1 unit square. Okay. So, and the circle has a radius of 1. Okay. So now I want to simulate or find out what is the value of the pi. So let's see how we'll be doing it. Okay. Let's see, this is a square and it's on the floor in the square. If I drop, let's say, 1000 grains of sand, and we'll find out the probability we'll calculate the number of grains falling inside the circle and the total number of grains. So here the area of a circle is given as pi r square. So 1/4 of that will be pi r square by 4, and r here is equal to 1. So its area is 1. So 1/4 of that will be pi by 4, and the area of the square is 1. Now the probability of the grains landing in the quarter circle will be outcomes inside the circle. There is the probability of landing inside the circle, or the number of landings inside the circle by the total grains that I have thrown, which is basically almost proportional to the area of the quarter circle by the area of the square, which is equal to pi by 4. So pi will be equal to 4 into area of the quarter circle by area of the square. Sorry, pi will be equal to number of grains in the quarter circle by the total number of grains. So pi almost equal to 4 into number of grains inside the quarter circle by the number of grains dropped. Okay, so this will be simulating using Monte Carlo simulation. We'll find out, we'll drop the process of dropping the grains which is basically will generate xy coordinate randomly. 1000 xy coordinates will be generating, and we'll find out whether those coordinates are inside the circle or outside the circle. If it is, we'll count the number of coordinates that is inside the circle divided by the total number of grains dropped, that will be 1000 in our case, and we'll multiply it by 4 to find out the value of the pi. So that will be simulating it. So this is I have done in Excel. So let's open Excel and we'll learn this particular simulation. Okay, so this is the case. So first, let's say random x random y. So we'll be using a function called rand to generate random number. When I use rand, it will generate random numbers between 0 and 1. So it is starting from 2. I want 1000, so I'll move to 1002. This how is it? 1. Yes. So this is my x coordinate. Similarly, I will generate separate independent random numbers for y. So this is independent y. This is independent y. Okay. So now I'll be plotting these two. Insert. So this I have plotted here. I want to make it a square size. So 1. Okay, so let's make it a square here. I'll make it 1 here, enter. So let me, now it appears to be a square. So this is a square, let's say of 1 radius or 1 length, 1 unit length, and I have dropped 1000 grains. So let me make it yellow, so it will represent markers. So color, let me make it yellowish. No line. Fill here yellow. Okay, so these are the, let me make it slightly. Okay, so these are the sand grains which I have dropped. Now I want to count how many grains are within this circle. So we know the equation of circle is x square plus y square is equal to r square. So here r is 1. So x square plus y square is equal to 1 square. Okay, so that is a circle. So if x square plus y square is less than 1, that means it lies within the circle. So here let me point out 1, if lies within circle, else 0. So if it is lies within circle, it will be 1, else it will be 0. So this equal to, if I use the function if this square plus this square I'll use a bracket here, is less than equal to 1, it is a circle, else it is outside the circle. So I'll drag it. Okay, so here I'll count specs inside circle equal to count if entire range equal to 1. Okay, so it will count the number of ones here. So using this function count if from this range to that range, if this becomes 1, it will keep on adding. So total number of grains that is inside the circle is 772 in this particular simulation. So my value of pi is equal to 4 star this divided by 1000. I have taken 1000, total number is 1000. So it is coming out to be, in this particular problem, it is coming out to be 3092. Now to simulate, so this is a one particular simulation. Now to simulate this, I'll be pressing F9 in Excel, and every will be simulating each time like this. So it is 3.12, this is 3.19, 3.14, the exact value is coming here. Now, as I have told you, Monte Carlo simulation does not give a exact results, but you can be close to exact result by conducting higher number of simulations. So let's say, let us do the experiment. So experiment number 1, 2, 3. So like that, if I keep on doing, let's say for the sake of understanding, let us do 10 experiments. Okay, so first experiment I have done, so it's coming out to be 3.92, sorry, let's say 3.092. okay, so now it is 3.14, 3.184, 3.02, 3.02, enter. 3.12, next trial 3.16, next trial 3.172, next trial 3.104, next trial 3.164, next trial 3.192, last trial 3.12. So if I take a mean of these, I should be very close to the results average. So you can see here it is 3.13. This is only 10 trials I have done. So if you do more trials, let's say 100 trials, then probably you will be very close. Okay, so this is how we'll be doing it. So if I plot just for representation, so this is how, and once you have the data, you can do n number of statistical analysis on it. It's up to you, and you can analyze the result accordingly. So that is an option here, and symbolically, if I want to represent it, let me draw a circle based on, or plot the points on the circle for all these excess values. Y values corresponding to random x. So for random x, I am finding out the y value and I'll plot it here. So this is equal to square root of 1 minus this square will give me the y values corresponding to this particular x. So this I will be plotting to generate the circle, so that it is, you can understand or visualize the problem. So here in this I will add data here. Select data, so I'll add one. So x values are this. You can use shortcut keys, fine, but I am dragging it. I like to drag. Okay, and y values will be all this. So this I plot, you will see all these values, 1000 values will be plotted here. It looks like a circle. It will look like a circle. So you can identify the border here. So this is the border here. If I make it black, okay, so this is the circle, and this is the grains falling inside the circle, and these are the grains outside the circle. Okay, so each time I want to simulate F9, 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 F9. So this is how you do simulation. This is a particular example of Monte Carlo simulations to find out the pi value. I hope you have understood this particular problem. So if you have any doubts, you can contact me, put it in the comments, and I will try to get back to you. And please watch this next video where we'll be using Monte Carlo simulations for business applications. Thank you for watching this video.